If you have used a calculator to model data, I'm going to be honest with you, both the Casio and the TI, um, they're great, but they don't show everything at one time. And Desmos does, and it's free, and it's built in to some assessment models like the Virginia SOL. So let's talk about how to do it. First, you're going to go to the Desmos Graphing app or website. Make sure you use the graphing calculator. Do not use the scientific calculator for this. So once you do that, you enter the data by hitting the plus sign in the upper left. It's always been there, but you've never used it or needed to. So you hit plus and you hit table. Then once you do that, you are going to enter it into X1 and Y1, which makes sense because we typically use X for input and Y for output. You can actually change them, but I would leave them alone. So you hit the plus sign, the table, you enter your data. Once you do that, okay, you're going to want to change your window so that the data will fit inside. Otherwise, it's kind of hard to zoom Desmos to get that to work. So once you type in your data that you've gotten from your problem, you use the wrench and you come down to the x-axis and you type in, for instance, in here I have -3 to 2. So I typed in Desmos, let's go from -5 to 5, because that is a window that will encompass all these numbers. And on the y-axis, I went from -40 to 40, because you can see I'm going from like -36 to 37. So I look at the domain and the range, and I made a window that would incorporate those. But what's great about Desmos, you can even label it time and position if you wanted to, if you're talking about a problem that has real life words in it, which is one of the main purposes of these kinds of problems. So then once you do that, you'll get a nice graph. I mean, look at that. It puts position and time on there because I entered it there. You have a nice graph that you can then ask yourself, like, what does that look like? Well, it's pretty darn linear. And so what you would do is you would then come back to this table and you would go below the table and you would type in y is approximately mx plus b. But instead of using equals, you have to use this approximation, this statistical and approximation, which is the upper left-hand corner of your keyboard if you hit that button, or you can find it in the Desmos keyboard, but you have to look around. It's right here, but you have to toggle the keyboard and then toggle in this corner. There's an ABC. You would want to hit the ABC. Now I've already hit it, so mine says 1, 2, 3 to go back to the number part of it. But when you toggle the keyboard, if you hit ABC right here, you'll see that little approximation right there. Now you have to do this anyway to put the subscripts in. So to put the subscripts in, you use this A lower B, and that is found in the keyboard. Again, toggle the keyboard and hit the ABC so that it comes up with the QWERTY keyboard, but it includes the subscript and also some other things that you might be wondering where they were, like theta and other things that are in here. All right, so once you do that, I picked y equals mx plus b because it was linear. It will immediately, when you click it, it'll immediately try to graph it. So here's a better picture of it. All right, so you can see that not all the lines intersect the line because it's an approximation. In this step, it gives you what the slope is, -14.6757. It tells you what the y-intercept is, -4.13514. And then you have these other things, and to explain to you what those are. R is called the coefficient of correlation. It gives the percentage as a decimal equivalent. Notice it's right, and it's negative because it has a negative slope. It would be positive if it were going upwards, and it's basically it's a way to determine if it modeled the data well. So think of this as like being very accurate. If this number is 1, it's perfectly linear or perfectly quadratic or perfectly cubic. And R squared is used in a higher level statistics class in which you're determining multivariate analysis. But we're really concerned about R. That's a nice R value. So this is how you do a line. We'll look at other examples in more detail with actual word problems, but you can do a line, a quadratic, a cubic, a quartic, an exponential, a natural log, or other things like a sine if you needed to. And all you do is simply put in the equations we learned in class, mx plus b, or a, b, c for quadratic. Cubics would be a, b, c, d. Quartics would be a, b, c, d, e. Exponential is exactly like you learned in class, and the natural log is a in front, ln x plus b, just like on the TI or the Casio. The exponential is going to come out in this model. The logarithmic, we're going to use ln. So it's not that hard to do, as long as you're willing to type in these things using the keyboard by hitting the ABC and changing it so you can put in the subscript and the approximation.